Good afternoon. So my name is Henrik. I'm a technology manager at a small consultancy agency called Above It. And I'm here today to talk to you about how you can create APIs that go beyond REST. So this is actually an experience talk where I want to show you how we use Kafka at Entur. Entur is a Norwegian firm that is building one single API for finding and buying trips with public transportation. They're currently offering tickets with buses, trams, boats, and trains in Norway. So when building this system, we did not opt for a true microservice architecture, but we chose an architecture where each individual business area would be represented by their own module. And a module could, for example, be a set of microservices, but in most cases, each module was implemented as a single application. All modules expose a REST API to interact with them, but we wanted to have some boundaries between modules, because we wanted to limit the amount of direct communication between modules. But this creates a problem, because we need to be able to let some information flow between them. So let me show you an example. The order module is absolutely dependent on knowing whether or not a payment has been completed in order to confirm an order. So we need information to flow between the payment module and the order module. And that is why we introduced Kafka to our system. Kafka is a distributed and scalable streaming platform, and a very important point for Entur. By using a streaming platform like Kafka, we created looser couplings between modules. So let's take a look at an example. When a payment has been completed in the payment module, it will push that fact to the Kafka cluster, and the order module is listening to these events. And doing this, we let information flow between the modules, and they can choose to react to them if they want to. Using a streaming platform like Kafka will create looser couplings between the modules, and every module will produce events to the Kafka cluster, and all applications listen for events that they need to know about. And this does actually provide some extra benefits as well. Because let's say that the accounting department would like to track every sale. They create their own module, and because we're using a streaming platform, none of the existing modules will have any code changes or will need to perform any code changes, because every event is already pushed to the stream. So the only thing that the accounting module or the accounting department will have to do is start listening for events. And one of the Kafka-specific benefits from this type of architecture is that Kafka can store all events since the beginning of time. So when the accounting application starts to listen for events, it can read all the sales that has happened since the beginning of time. So REST versus Kafka, which one should you choose? Well, you shouldn't choose one, because synchronous versus asynchronous APIs doesn't make sense, because we can't just stop accepting synchronous requests. So we will need to combine them. Kafka, for example, will help you evolve your APIs to another level. So let's take a look at another example. Entur provides one unified sales and ticketing system that anyone who wishes to start a travel agency can use. And as of today, there are at least 3 different apps where you can buy tickets using the Entur API. But each agency or operator might have different needs. So the receipt module will usually react to an order confirmed event and send a receipt to the customer's email address. But one of the operators doesn't want us to send the receipts to the customers. OK, no problem. We will just react to the order confirmed event as we used to. But when we get an event from an order that has been sold through that specific app, we do nothing instead of sending the receipt. But how will now the operator know if the sale has been completed? Well, with Kafka, we can create something called a stream processing module. Their task is to read one or more streams, process the data, and publish them to an external cluster. So if a sale was processed through the app from operator number 2, then we publish that sale to a stream specifically for that operator. So what should be the key takeaways from this Ignite? Well, evolve your APIs. The benefits of combining a request-response type of communication with a streaming platform like Kafka are huge. And thank you so much.